So here we have only one forward path. That's why I am saying we consider del1 equal to 1. So forward path gain becomes 1 by s. So this is my state signal flow graph for the first transfer function, that means for 1 over s plus 2. Similarly, we can draw the state signal flow graph for second transfer function, that means for 1 over s plus 3, by considering second state variable x2. In same way, we can draw the state signal flow graph for the third transfer function, that means for 1 over s plus 4, by considering third state variable x3. After that, we can draw the complete state diagram by combining the state diagram for each transfer function. Now let us see how we can draw the complete state diagram or complete state signal flow graph. So according to given transfer function, this is a state signal flow graph for the first transfer function, that means for 1 over s plus 2. This is my first transfer function. Now let us see state signal flow graph for the given transfer function, that means for y over u. So first we will define the node for the input variable u. Then we will define node for x1 dot, then for x1, then for x2 dot, next node for x2, next node for x3 dot, next node for x3, last node for y. If we multiply 1 by s with x1 dot, we will get x1. Similarly, if we will multiply x1 dot with 1 by s, we will get x2, and to get x3 we will multiply x3 dot with 1 by s. We are connecting all three in a cascade manner. So between x1 and x2 dot we have branch transmittance 1. Similarly, between x2 and x3 dot we have branch transmittance 1. Now let us see. For first transfer function, we have loop gain minus 2 by s. For second transfer function, we have loop gain minus 3 by s. And for third transfer function, we have loop gain minus 4 by s. Similarly, between x3 and y, we have branch transmittance 1. So this is my state signal flow graph or a state diagram for the given transfer function. With the help of state signal flow graph, we can determine the state model. Here we have three state variables. So we have three state equations. First for x1 dot. According to the diagram, we can write x1 dot equal to minus 2x1 plus u. Similarly, x2 dot, we have minus 3x2 plus x1. Similarly, x3 dot, we have minus 4x3 plus x2. So first we'll define state equation, second we'll define state equation, third will also define state equation. So all three will define state equations. Output equation, we have y equal to x3. This is my output equation. With the help of state equation and output equation, we can define a state model in a matrix form. So from first state equation, from second and from third state equation, we have a matrix form of state equations according to x1 dot, x2 dot, x3 dot equal to minus 2 0 0 0 sorry 1 minus 3 1 minus 3 0. And from third state equation, we have 0 1 minus 4 0 1 minus 4. State variables, we have x1 x2 x3 plus 1 0 0 u. So this is my state equation in matrix form. A will define a state equation in matrix form. Similarly, we can define a output equation in matrix form. So equation B will define output equation in matrix form. A and B combinedly defines state model. For the given transfer function using a cascade decomposition. Thank you.